right, now we're going to look at composition of functions. So notice composition is different than multiplication, but looks really similar. So my difference comes in with this symbol here. So this open circle is not multiply, but I read it as the word of. So given functions f and g, their composition f of g of x is defined by, well, it's when I take g and whatever that function is, I plug it into x's function as the input. So the domain of g, so x is an element of the domain of g. So I put all my x's in to g. Whatever comes out, that's what I put into f. So x is an element of the domain of g, and the output, the range of g, so this is the range of g, because remember g of x is like the y values. So the range of g is the domain of f. So if I want to think about this, I start with x, I put it into g of x, whatever comes out, I put that into f. So this becomes f of the output. Well, I want to try and think of this as one step so that I can plug in the x and get the final output. So let's look at that with an example. So if f of x is 2x minus 1 and g of x is x squared, well, if I want to find f of g of 2, I start with g of 2, and that's going to give me 2 squared, which is 4. So then f of g of 2 becomes f of 4, which then becomes 2 times 4 minus 1 is going to be 7. But when we compose, really we want a single function that will take us from x equals 2 to y equals 7 directly. So let's think of what f of g of x looks like. So I'm going to put my x in g. Well, I know if I put my x in g, I just get x squared. So then I'm going to put x squared into f. So now I'm going to take this x squared and replace the x value with x squared. So I'm going to get 2x squared minus 1. Well, let's test it. So that's going to be 2 times 2 squared minus 1. Well, 4 times 2 is 8 minus 1 gives me my 7. So this would be the single function that represents the composition of those two functions. Well, I hope this has you wondering, does f of g of x equal g of f of x? Let's see. So if I was going to do g of f of x for my function above, then I'm going to get g of 2x minus 1. So now I'm going to take this, put it into my g, which means I'm going to square it. Well, this is equal to 4x squared minus 4x plus 1, which does not equal 2x squared minus 1. So only rarely will f of g of x and g of f of x be equal. Almost always they are not equal.